friends, welcome back to our channel. So in the previous session we have started the trees concept and we have covered the tree terminology. So in that we have seen what is a leaf node, what is a parent node, what is a child node, what is a degree, what is a level, what is a depth. So and like this we have seen a few terminologies which are used for implementing the trees, right? So in this session we will go with the binary tree. What is the introduction to binary tree and what are the types of binary tree? See, the name itself indicates binary means binary digits. That means only two numbers, that is 0 or 1. That means two numbers. So a binary tree is defined as every node in a tree should have at most two children. At most two children. So every node in a tree should have at most two children. Then that tree is called as a binary tree. So see, at most 2. So at most 2 means a tree can have 0 nodes or 1 node or 2 nodes. So that means 0, 1 or 2. So if every node in a tree is having these nodes, that means either 0 or 1 or 2 nodes, that particular tree is called as a binary tree. See, if you consider an example, so we know that this is called a tree. This is called a tree. This is not a binary tree. It's a tree but not a binary tree, because here A is a root node which is having 3 children. So this is a normal tree, right? But our binary tree means every node should have at most 2 children. So see, A, B, C, this is called binary tree. Okay, this is called a binary tree. Even this is also a binary tree because every node is having at most 2 children. So A is having 2 children, B is having 2 children, C is having 2 children, D is having 2 children, and E is a leaf node. So it can also have a 0 nodes. So E, F and G. So this is called binary tree. This is called a binary tree. So this is the difference between a tree and a binary tree, right? So there are different types of binary trees. So we'll go with that. So just remember, binary means a 2 digits. So every node can have at most 2 children. Types of binary trees. First one, full binary tree, or this can also be called as strictly binary tree. Second one, almost complete binary tree, or incomplete binary tree. incomplete binary tree. Next, complete binary tree, or it can also be called as perfect binary tree, and left skewed binary tree, and right skewed binary tree. So these are the few types of binary trees. So different types of binary trees. So full binary tree or a strictly binary tree, and almost complete binary tree or incomplete binary tree. So complete binary tree or a perfect binary tree, left skewed binary tree, and a right skewed binary tree. Now let us see one by one with an example so that you will be better understanding. First, full binary tree or strictly binary tree. Full binary or strictly binary. See here, every node must have two children. Every node must have two children, except the leaf nodes. Except the leaf nodes. Right? So, if every node is having two children except the leaf nodes, that is called full binary tree. So, I will show you that. See, this is a binary tree but not the full binary tree, because here what's the definition? Every node must have a two children except the leaf node. So here A is having two children, B is having two children, and C is having only one children. So that's why this is called a binary tree but not the full binary tree or a strictly binary tree. So this is called a binary tree. This is a full binary tree, because here if you observe, every parent is having two children. So A is a parent, so it is having two children. B is a parent, it's having two children. D is a parent, it's having two children. Right? Here E is also a parent, it's having two children. So it satisfies the definition of full binary tree. So this is called strictly binary tree. Right? So hope you understood this one. So if every node in a tree is having two children except the leaf nodes, so here the leaf nodes are F, G, H, I and C. So except the leaf nodes, if every parent is having two children, then we can call it as a strictly binary tree. Right? Now, incomplete binary or almost complete binary. incomplete binary or almost complete binary. So here every node must have two children every node must have two children in all the levels. So we know that levels, so hierarchy wise the levels will be incremented. So root node level is 0 and the next hierarchy will be level 1, next hierarchy will be level 2. So every node must have two children in all levels except in last level, except in the last level, but filled from left to right. Left to right, that means first the left child should be written and then right child should be written. So in the last level, possibility in the last level, at least the left should be happened. Okay, the left should be inserted but not the right. See example. So this is a strictly binary tree. This is a strictly binary tree, but not this incomplete binary tree, because here every node must have two children on all levels. So here in the 0th level, so this is the first level. So in the first level, if you observe, two nodes are there. So for the B we are having two children, but here for C there is no two children. Okay, it's a leaf node. So it doesn't satisfy the definition of incomplete binary tree. So this is called strictly binary tree. Strictly binary tree. And so see, this is called incomplete binary tree, because in the level 0, so in the level 1 there are two nodes. So for the two nodes they are having two children, so B and C. So in the level 2, okay, in the level 2, I mean possibility the last level, this is the last level, because in the next level we are having only leaf nodes, right? So in the 2 there are 4 nodes and possibly C, except in the last level filled with from left to right. So first left must be, at least the left must be satisfied. That means the elements, the nodes should be filled in the left side. So in D it is having a two nodes which is on the left child and the right child, and so this is called incomplete binary tree. Incomplete or almost complete. So here see, if the tree is like this, if the tree is like this, this is not incomplete, because here we are not having the left child for node E, but we are having the right child for E. So first it is filled from left to right. So first left child should be written and then only the right child should be written. So here it doesn't satisfy the condition of almost complete tree. So this is not an incomplete binary tree if there is a node J for E node. Okay, so in the absence of this one, this is a incomplete binary tree. Okay, so hope you understood. So in all the levels, every node should have two children, except a possibility for last level. Okay, now we will go with the next one, that is complete binary tree perfect binary tree. Complete binary tree or perfect binary tree. So here every node must have two children in all the levels. In all the levels, or simply we can say each level there must be 2 power L nodes, where L is a level. Right. So if this satisfies, then simply we can say the tree as a complete binary tree. That means, so each level, in each level there must be 2 power L nodes. See, so this is not a complete binary tree, because see, this is a level 0, this is level 1, this is level 2, and this is level 3. So according to the definition, for the level 0, 0th level, there must be 2 power 0, that is equal to 1 node. Satisfies. First level, 2 power 1 nodes, that is 2 nodes must be there. Right, P and C. Second level, 2 power 2, that is equal to 4 nodes. But there are only 2 nodes, so it doesn't satisfy here. Right? So that's why this is not a complete binary tree. Now, so this is not a complete binary tree. This is a binary tree, but not a complete binary tree. It is a binary tree because the binary tree definition means every node must have at most 2 children. So it is having at most 2 children. So this is called a binary tree, right? So if you take an example, see, this is called a complete binary tree because, so this is at level 0, this is 1, this is 2, and this is 3. So these are the levels. So 0th level, there must be 2 power 0 nodes, that is 1 node, which is nothing but A, and first level, 2 power 1 is equal to 2 nodes, that is equal to B comma C. See, if you observe 2 nodes. So at level 2, 2 power 2 is equal to 4 nodes, D, E, F, G. D, E, F, G. Level 3, sorry, 2 power 3 nodes, 8 nodes are there. Those are H, I, J, K, L, M, N, and O. See, if you observe this one, so this tree satisfies the definition of the complete binary tree. So every level should have the equal number of nodes. I mean, the 2 power L nodes. For every level L, there must be 2 power L nodes. So every node must have 2 children, and it completes in all the levels. So this is the definition for the complete. So if a tree is like this, this is called complete binary tree. This is called a complete binary tree, right? So hope you understood this one, complete binary tree. So this is not a complete binary tree because it doesn't satisfy this condition, 2 power L nodes in each level. Right. Now we'll go with another one. Next one is left skewed binary tree. Left skewed binary tree. So left skewed binary tree means a tree should contain only the left childs. So every node should have only left childs. Only the left children. So example, A, the left children is B, the left children is C, the left children is D, and the left children is E. So this is called left skewed. So this is also a binary tree because our binary tree definition is every node in a tree should have at most 2 children. At most 2 children means either it can have a 0, 1 or 2. Here every node is having only 1 children. So it satisfies the definition of a binary tree, but it is a left skewed binary tree because every node is having only the left child. Right. So this is called a left skewed binary tree. Then right skewed binary tree. Every node should have only the right children. Every node should have only the right children. So the same thing, A, B, C, D, C. This is called a right skewed. It will be having only the right children. So every node will be having the right children. So this is called a left skewed. This is called the right skewed. Right? So hope you understood this one. So these are all different types of binary trees. So we have seen the definition of a binary tree, and then we have seen the types of binary trees. So in that we have seen the incomplete binary tree, strictly binary tree, complete binary tree, as well as the perfect binary tree, and left skewed and right skewed. So this is a binary tree. So this is complete binary tree. Okay, sorry. This is a strictly binary tree. So this is incomplete binary or almost complete binary. Almost complete binary. This is a complete binary. Or we can say it is perfect binary. This is left skewed binary. This is right skewed binary. Right? So these are the different types of binaries. You can say This is called tree. Right? So we have seen all these things. So first, a tree, a node can consist of an n number of children. So this is a tree, and if every node is having at most 2 children, that is a binary tree. So here every node is having at most 2 children. So if every node is having 2 children except the leaf, that is called a strictly binary. Incomplete binary tree, that means every node should have the 2 children in all the levels except the last level, and that also should be filled from left to right. So this is an incomplete binary tree, and this is a complete binary tree because every level should have 2 power L nodes. That means all the levels should have, all the levels should have the corresponding nodes, and all the leaf nodes should be at the same level. This is a left skewed, so every node should have the left child only. Every node should have the right child only. That is called right skewed. Right. So hope you understood the difference between all these things. So if you are having any doubts regarding this, so feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.